Hello everyone, I am Asadullah Al-Khalid. In this session, I will briefly go over the key findings presented in my paper titled Large-Scale Web Crawling and Distributed Search Engines, Techniques, Challenges, Current Trends and Future Prospects. This was presented at the International Conference on Computing and Informatics ICOCI 2023 in Kuala Lumpur, Malaysia. The paper is published in Communications in Computer and Information Science by Springer. You can follow the link provided in the description to view the complete paper. The core component of any search engine is a crawler. It is simply a program that finds and collects web pages by following links from previously visited pages. This way, it finds new pages and sites all by itself without being specifically programmed. Today's web crawlers have evolved tremendously since their first inception, and they are constantly evolving in their ability to index more of the ever-expanding internet. Websites found on the internet today vary quite a lot in terms of site structure as well as types of the content. Modern crawlers from mega search engines need to deal with this variety on a daily basis. In this paper, we surveyed the current state of web crawling, focusing specifically on deep web crawling. We also looked into distributed search engines and how the landscape has changed since the arrival of large language models like ChatGPT or Bard. And finally, we presented a prototype of a new asynchronous crawler that can generate structured and formatted information from any domain that contains unstructured content of interest. First, crawling. Basic web crawler consists of three main components: a list of seed URLs that acts as a starting point for the crawler, then an aggregator that collects web pages, and finally a parsing module that extracts new links to visit from the page content. The crawler repeats these three steps until the URL list becomes empty or the crawler reaches some predefined thresholds for termination. Crawlers can be divided into various categories such as universal or broad crawlers, topical crawlers, forum crawlers based on their scope and the nature of information that they collect. Another major type is the hidden or deep web crawler. These crawlers use the search panels or user interfaces found on the website for querying information and retrieves information from the underlying databases or storage systems by utilizing these search queries. Crawling techniques can be further divided into three main categories based on whether the entire crawling process is run on a single or distributed set of instances. Hybrid crawling tries to combine the simplicity of centralized crawling with the scalability of distributed crawling. Details of these techniques can be found in the paper. Recently, the emergence of cheap cloud services combined with various open source frameworks have given rise to a diverse set of distributed crawling architectures. Some of these approaches are Scrapy and Redis-based system, container clustering, and Apache Spark-based system on the master worker architecture. You can find details of these techniques in the paper. Now, some challenges and prospects facing the modern web crawlers. As the internet keeps growing at a rapid speed with no sign of slowing down, modern crawlers need to balance between finding new pages fast and updating already visited page index. As the realm of front-end libraries and frameworks keeps getting complex, deep web crawlers constantly need to reinvent to keep up with the changes needed to query the underlying data storage systems for hidden data using complex user interfaces. But it's not all the bad news. Machine learning can be used to generate better queries that require few interactions with the search panels on the websites so that it maximizes the information collection from hidden part of the web. Take a look at the paper for further details. Now, distributed search engine part. A search engine consists of many complex and sophisticated modules, each handling a specific part of the whole process. In distributed or decentralized search engine, the responsibility of various components is shared among multiple nodes. For distributed search engines to be useful in the real world, these constraints must be met in an efficient, scalable, and cost-effective way. Some examples of peer-to-peer search engines include Nutella and YSY. Details of these approaches and their drawbacks are detailed in the paper. While the most popular search engines like Google, Bing, or Baidu are commercial projects, there are some powerful open source indexing and search engine frameworks that are used quite extensively to build search applications, and some of these are Apache Lucene and Elasticsearch. Now, the challenges and future prospects of distributed search engines. Even though the idea of an open and censor-free web is very promising, there are major technical and practical challenges in this domain. Current implementations of peer-to-peer search engines are not equipped to deal with internet-scale search queries in a cost-effective and efficient manner. Extensive research is also needed to prevent attacks on these P2P systems from adversarial players. Now we'll look at the hot topic of the internet, that is AI conversational agents, and we'll look at their impacts on search engines and crawling. ChatGPT, which is well known now, is based on GPT-3, a large language model trained on the petabytes of data to produce human-like text. It can be used for a variety of tasks such as conversational agent, summarizing text, correcting grammar, explaining technical topics, generating functional code, and many more. So, what are some challenges to using these LLMs as search engines? So, first is hallucinations. So, hallucination is a major problem when it comes to LLMs answering questions on various topics. So instead of simply showing no results found like the traditional search engines do, these LLMs have a tendency to make up answers no matter how dubious it sounds. These models also pose significant challenges in social and ethical domain. As they are trained on human-generated text script from the internet, the models pick up the bias during training and then later reflect the inherent bias existing in the model during the text generation phase. As the models get better at generating texts that are frighteningly similar to human-generated ones, spreading misinformation will get much easier now, and this will exacerbate the already fragile social and political divides across the world. To combat this, a key area of research effort should be directed to providing reference along with the generated content for end-user verification. And also much more attention should be given to debiasing the training datasets. Now we look at the domain agnostic asynchronous crawler. The intention behind this domain agnostic crawler is to design an open source crawling engine that can crawl through hundreds of predefined sites with diverse range of content types and layout structures with very minimal configuration and setup. This is not a traditional search engine crawler, however. Given some basic extraction rules, this crawler can fetch raw content and produce structured data from sites of any domain. So now we look at the architecture of this asynchronous crawler. So this crawler has four major components. First, the orchestrator, then the base crawler, and then after that the site handler, and finally utility modules. So first we'll look at the orchestrator part. So orchestrator is the starting point of this crawling engine. So given a list of seed URLs, orchestrator loads corresponding handler module from the local directory. Using this approach, multiple sites can be mapped to same handler and use common scraping and parsing logic without the need to duplicate code. Finally, when all of these steps are executed, the orchestrator creates separate asynchronous crawling tasks for each site and initiates them all at once. Then the base crawler or the specific site handler takes over. So base crawler is the root class that defines the structure of every site handler. So if you recall, each site is mapped to a particular site handler. Here the handler gets initialized first and then site-specific pagination information is extracted. For each page, the site crawler creates an asynchronous task and initiates them all at once. Now we'll look at the page handler part. So all the items that are available on this page are extracted first. Then the page handler, rather the individual page handler, creates an asynchronous task for each item and initiates all those item handler at once. Each item handler then initializes the item depending on the site. How to do that is configured and the instructions are provided in a particular site handler. Then all the record information is collected in an asynchronous process, and finally, when the item is ready, the storage module then stores all this information, these items, in Amazon DynamoDB. So we tested the single-threaded asynchronous crawler with its synchronous version over 2 e-commerce sites. In total, 2 sites had around 200 pages in total. The synchronous version took 382 minutes altogether to complete extracting content from 200 pages, and each of which had dozens of individual items. whereas the asynchronous version took only 79 minutes for the same task. This asynchronous crawler supports extracting formatted content from sites that contain data in the list view and details view structure. Using this crawler, handlers for a variety of sites can be created within hours rather than days. There are some limitations, however, with this current version. The crawler needs to keep extensive logs of all API calls as well as errors that occur at each stage of the crawling. Since all of these are done in an asynchronous way, the logs play a vital role in finding out any issues regarding the API calls. The crawler also needs to include a retry mechanism to reinitiate crawling for failed sites due to network or other connectivity issues without any human intervention. So in this paper, we explored the current status of modern web crawlers and the techniques that are being used to adapt to ever-changing nature of the internet. We shed light on distributed search engines and the critical problems that need to be solved to serve user queries at internet scale. We touched upon distributed crawling techniques utilizing various open source frameworks and the power of cloud services. We then looked into the use of large language models and how they have revolutionized the way we look for information on the web and their implications on traditional search engines. And finally, we described the domain-agnostic asynchronous crawler in detail and showed the performance improvement of a simple single-threaded asynchronous crawler over its synchronous version. So this is all. Thank you.